Dear students, today we are going to study about the language of chemistry. Now, in this language of chemistry, first of all, we are going to study about the symbol of an element. So, what is symbol? A symbol is a one atom of an element. It represents one atom of the element. Like if I write P, that means it is representing one atom of element phosphorus. The symbol also represents the weight of the element equal to its atomic weight. Now, the term symbol was introduced by a scientist in 1807 named John Dalton. Now, Berzelius in 1814 he suggested a simple system of representing elements with symbols. He put forward certain points like in most cases the first letter of the name of an element was taken as symbol. First letter of an element was taken as the symbol for that element and written in capitals. In cases where the first letter is already adopted, the initial letter in capital together with its small letter from its name was used. Example: calcium, silicon. Now, the symbols for some metals were derived from their Latin name, like copper from cuprum, then iron from ferrum, potassium from kalium, then gold from aurum, and like so on. Now, coming to the next point, that is valency. Now, what is valency? The number of hydrogen atoms. The number of hydrogen atoms which can combine with or displace one atom of the element or radical so as to form a compound. The valency of all metals and hydrogen is considered positive. Metals and hydrogen, and the valency of non-metals is taken as negative. The valency of a metal is the number of electrons lost per atom of the metal. Like potassium, it is having one electron more in its outermost shell. So, in order to become stable, it loses its one electron and becomes positively charged. And its valency is 1, so they are known as univalent. Now for magnesium, it is having 2 more electrons in its outermost shell, so it is having the valency 2 plus, that we call as divalent elements. Then aluminium, it is having 3 more electrons in its outermost shell, So it loses 3 electrons and becomes positively charged. So now aluminium Al plus 3. So plus 3 is the valency of aluminium. Now considering next point, that is valency of a non-metal. So what is valency of non-metal? Valency of a non-metal is the number of electrons gained per atom of the non-metal. If I say, we take example of nitrogen. Nitrogen is having 5 electrons in its outermost shell. Its electronic configuration, if we write its electronic configuration, it is 2 5 because its atomic number is 7. So now it is having 5 electrons in its outermost shell. To complete its octet, or in order to become stable, it gains 3 electrons. So now when it gains 3 electrons, its valency becomes N3 minus. Now this 3 we call it as trivalent. So nitrogen is trivalent. If I say about chlorine, its atomic number is 17. So its electronic configuration is 287. Now it is having 7 electrons in its outermost shell. So it requires one more electron to complete its octet. So it will be gaining one more electron and will become Cl1 minus. So 1 minus is its valency. We can say that it is univalent. Now if we take example of sulfur. Sulfur is having 2 electrons less in its outermost shell, so that it will be taking, so now it will be S2 minus, so it will be having 2 minus valency, that is it is divalent. Now coming to the next topic, that is variable valency. So what is variable valency? Some of the metals, they exhibit more than one valency, and so it is said to that these elements are showing variable valency. Now why do the variable valency is exhibiting? An atom or an element can sometimes lose more electrons than are present in its valence shell. That is, it loses from penultimate shell. That is, penultimate shell before last shell. So it exhibits more than one valency. For example, iron is having two valency, iron Fe2 plus and Fe3 plus. In the similar way, copper is having two valency, that is Cu1 plus and Cu2 plus. Now the smaller one, that is Fe2 plus. So suffix OUS will be added here. So we will be naming it as ferrous, and here the bigger one, the valency which is bigger than the first one, that is named as ferric, because here the suffix IC is added. In the similar way, in copper, where 1 plus valency is there, so we will be adding the suffix OUS, and here we will be adding the suffix IC. So its name will be Cu1 plus. The name of Cu1 plus is cuprous and the name of Cu2 plus will be cupric. Now, after this, the topic radicals. Now, what is radical? A radical is a group of atoms of elements that behaves like a single unit and shows a valency. Positive radical, if I say ammonium NH4 1 plus, and negative radical, that is nitrite, nitrate, hydroxide, and so on. Now coming to next topic, that is chemical formula. So what is chemical formula? Chemical formula is the representation of a molecule of a substance, that is element or compound, by symbols. Now, an element is said to be monoatomic when it exists as a single atom and represented by a single symbol of that element. For example, sodium, potassium. So when an element exists as a molecule, a number representing its atomicity is written as a subscript after the symbol of the element and therefore represents its formula. Now, a compound. It contains whole number of atoms of the component elements, indicating that the elements are in chemical combination and thereby represents its molecular formula. Now the fourth point, a molecular formula also indicates the number of units of the radicals present in a compound with the proper subscript outside the unit of the radical. Now, if magnesium hydroxide is there, so now this 2, it is the subscript which is outside the unit of radical. So now coming to the valency chart. First of all, positive ions or radicals. Potassium, sodium, lithium, hydrogen, ammonium. These are all monovalent elements. If I speak about the variable valencies, cuprous, that is Cu1 plus, argenteous, that is Ag1 plus, mercurous, that is Hg1 plus, and Aurus, that is gold, Au1 plus. Now all these are again monovalent elements. Now coming to divalent elements. Divalent elements are, example we can take of calcium, that is Ca2 plus, magnesium Mg2 plus, zinc Zn2 plus, barium Ba2 plus, nickel Ni2 plus, cobalt CO2 plus, uranium U2 plus. All these are having 2 plus valency, so they are known as divalent elements. Now if we say about the elements which possess variable valency, so for that, for copper it is cupric Cu2 plus, argentic Ag2 plus, mercuric Hg2 plus, ferrous Fe2 plus, plumbous Pb2 plus, stannous Sn2 plus, platinous Pt2 plus, and manganese Mn2 plus. So these all elements which show variable valency, they possess 2 plus valency, so they are also divalent elements. Now coming to trivalent elements. The elements which possess 3 valency, they are known as trivalent elements. In this, we have aluminium Al3 plus, then chromium Cr3 plus. Now if I say about those elements which possess variable valency, and that Fe, that is ferric 3 plus, auric Au 3 plus. So now all these atoms of the elements, they are possessing 3 plus valency, so they are those elements which are known as trivalent. Now coming to negative ions or radicals. In this we will see that again about monovalent elements. Now if I say chloride, it is Cl1 minus, chlorate, it is ClO31 minus, hypochlorite, that is ClO1 minus, bromide Br1 minus, iodide I1 minus, hydroxide OH1 minus, nitrite NO2 1 minus, nitrate NO3 1 minus, hydrogen bicarbonate HCO3 1 minus, hydrogen bisulfate HSO4 1 minus, hydrogen bisulfite HSO3 1 minus, and permanganate, that is MnO4 1 minus. So all these are negative radicals having 1 minus valency, so they are known to be monovalent elements. Now coming to divalent elements, those elements having 2 valency. Now if I say sulfite SO3 having 2 minus valency, SO4 2 minus, sulfide S2 minus, oxide O2 minus, chromate CrO4 2 minus, dichromate Cr2O7 2 minus, peroxide O2 2 minus, silicate SiO3 2 minus, zincate ZnO2 2 minus, plumbite PbO2 2 minus. So all these are the radicals that are containing 2 valency. They are known as divalent elements. So all these elements are negative radicals. Now coming to trivalent elements. Trivalent elements are those elements which possess 3 valency. For example, phosphate PO4 3 minus, phosphite PO3 3 minus, nitrite N3 minus. So these elements are possessing 3 valency, so they are known as trivalent elements. Now coming to next topic, that is compound. So what is compound? Compound is a pure substance composed of 2 or more elements. So we can define it as a pure substance composed of 2 or more elements chemically combined in a fixed proportion. The characteristics of compound are: the components present in compound are always present in a definite proportion. Compound is always homogeneous. Particles in a compound are of one kind. Compound has a definite set of properties. Components in a compound do not retain their original properties and can be separated only by chemical means. So here there are chemical formula of different compounds as well as elements present in that compound. The molecular formula for hydrochloric acid is HCl. The elements present in HCl are hydrogen and chlorine. Number 2 is nitric acid. The elements present in nitric acid are hydrogen, nitrogen and oxygen. Then the third one is sulfuric acid. The elements present in sulfuric acid are hydrogen, sulfur and oxygen. Then potassium hydroxide. Molecular formula for potassium hydroxide is KOH. The elements present in potassium hydroxide are potassium, oxygen, and hydrogen. Number 5. Calcium hydroxide. The elements which are present in calcium hydroxide are calcium, oxygen, and hydrogen. Now taking example of salt, that is lead sulfate, having elements lead, sulfur, and oxygen. So these are the formula of compounds as well as elements present in the compound. Now how to write the formula of chemical? Write the symbols of the positive atom or radical on the left side and the symbol of the negative atom or radical on right side. Now if it is potassium chloride, so now this is the positive atom and this is the negative atom. So now in the step 2 we have to write down the valency number on the symbol of each atom or radical on its top right. So here we can see the valency of potassium as 1 plus and chloride as 1 minus. Now step 3. Interchange the valency number of each atom or radical and shift it to the lower side of the atom or radical. Now potassium, this is chloride. So 1 I have shifted over here and lower here to the lower right side and 1 over here. We have to ignore the plus and the negative sign. Now if the valency number of the radical in the compound is above 2, then enclose the radical in bracket with the numbers on the right of the bracket at the both like the bottom ends. Now in the step 4, write down the formula of the compound. Now see, we can write down the formula of the compound. It is KCl. So now there are certain rules in naming chemical compounds. Now if it is a metal and non-metal, in case of metal and non-metal, metal is written first and non-metal is given a suffix IDE, like compound containing potassium and bromine. Potassium K is a metal plus bromine is non-metal. So the formula will be potassium bromide. So now K, B, R. If it is containing only two metals, so non-metals, they are written side by side and given as prefix mono, di, tri, etc., denoting the number of atoms. Now, for example, oxide of carbon, CO2. So the name will be carbon dioxide. Two atoms of oxygen it is containing. Now the third one, two elements and oxygen. Two elements and oxygen. Two elements written side by side. Oxygen is written after it, and then oxygen is named with suffix ate or ite. For example, sodium chlorate, NaClO2. So, and if it is sodium chloride, NaClO3. So in this way, these compounds are named. Thank you, dear children, for watching this video. I hope you will like it.